I just wanted to make a quick video on levers for anybody who's kind of still struggling with that, or just maybe not crystal clear on it, because I know Dr. Owens didn't really like teach it. He just kind of like brushed over it and said, oh yeah, this can be confusing, just make sure you know it. And unfortunately the book is trash, so it doesn't really go into detail on how to differentiate between the different lever systems. So I'm just going to run through it as fast as I can, to help anybody who's like still stuck on that. So I have this acronym over here, FAR, ARF, and AFR, or FAR, ARF, AFR, and that's just how I say it in my head to remember. But basically what these little letters mean is F is going to be my muscle force or internal force, right? We speak in terms of internal and external forces, so I can convert it after. My A is my axis, and my F, so I said that was internal, and then the R is the resistance, or we speak in terms of external force. So if I wanted to translate this, it doesn't matter what terms you use. You can say internal, external, you can say muscle and load. It does not matter. So I'm just going to translate this to internal and external forces. So I said my muscle force is my internal force, A is axis, and R means my external force, right? My resistance is my external force. So that means first class lever. And for second class lever, A and resistance is my external force, and my muscle force is my internal force, right? And then for third class, I have A, and my muscle force is internal, and then resistance is external. So whichever letters you want to use, if you wanted to use muscle and load, you can literally translate, this like this to an L for load, and then axis would still be axis, and then your muscle force can be M. It doesn't matter, whatever you want to write it as. If you don't want to memorize like the whole entire thing, you could also technically just memorize what's in the middle, because theoretically, if you just kind of wrote down ARF or even AEI, if you just wrote that down on your test paper before you started taking the test, and I just write AEI, and that's 1, 2, and 3, right? I just got to write the other things around it. So because I didn't say this before, but basically, no matter whether this reads forward or backwards, it is what it is, whether this is FAR or RA or RAF. That is still a first class lever. It's just linear, forward or backward, it doesn't matter. So if I write down what's in the middle, right? If I write down what's in the middle, I can just write the other things around it. So I have an A, so I need to write an I somewhere, and I need to write an E somewhere. And then I have an E, I need to write an I somewhere, and then an A somewhere. And then I have an I, so I need an A, and then I need, what's missing? Oh, an E. All right, so that equals first, that equals second class, and that equals third class. I'm going to move this so that I'm not running into things. All right, because, again, this is technically the same thing as EAI, right? And this is the same thing as IEA. Doesn't matter if it's forward or backwards. This is the same thing as EIA, all right? So that's still first, second, third. All right, so now why does this matter? Well, this is the order in which those points lie is going to tell you whether something or some action that's happening is first, second, or third class. All right. So I'm going to go through an example. Elbow flexion, right? Because it's easy. I'm going to draw a humerus. That's the elbow joint, and that is my hand. So I need to know my axis, which I know it's at the capitulum over there on the humerus, and I have to know, in order to know where my muscle force lies, in order to know where that is, or my internal force, I really have to know my insertion point. So if you don't know your insertion points, this is going to be kind of like trying to learn how to read without knowing the alphabet. So if you don't know those, like for your primary muscle, the primary muscle movers of your major joint motions, I would go ahead and like look at those and review those. Just know like the big ones. Know where the quads insert, because you think knee extension, oh quads, knee flexion, oh hamstrings, dorsiflexion, oh that's tibialis anterior, gastroc is for plantar flexion. So know the insertions, because where you put those when you draw this out is going to matter, and I'll show you why in a second, because it had to do with our lab activity. So I'm going to draw so this is my axis. I'm going to draw in a different color. My axis. And I know that the bicep inserts on the proximal radius, right? And it pulls that way. And if I was holding like a 10-pound weight, my load or my resistance or external force is always distal, right? So gravity pulls it straight down. So I'm going to label these points. I have my axis labeled. I have my internal force from the bicep insertion. And then I have my external force, or my load, right? And how this reads linearly is AIE. So AIE, that tells me that's a third class lever. So elbow flexion is a third class lever, all right? Now we'll do tricep extension, or elbow extension. So I'm going to draw out this exercise, right? And I have this little screenshot that I took to have an anatomical reference, because if I'm not sure where the tricep inserts, right, I'm going to look it up. So that's the olecranon process, right? And if I kind of move that, I know that the axis is going to be the axis is going to be through the capitulum, right? So and then if I look at so that's where the axis is going to be, through the capitulum. So I'm going to draw a little dot there. And then my insertion from the triceps is over here. And I know my load is somewhere down here distally. So I know that that's my external force, right? This is my axis. And then this is my insertion. So EAI. So what did we say earlier? EAI. EAI, that's first class lever. Now, if I were to draw this, and I just wanted to draw it on my test, just to make sure, if he said, oh, what kind of lever system is tricep extension, all right? If I was going to draw someone like supine or something, doing like that tricep exercise where you kind of lift the weight up that way, right? let's do a different color. I know my axis is going to be there. My load or my resistance or external force is going to be over here. And then my muscle insertion is going to be distal to the axis, because I saw that over here. It's, or I won't say distal, I'm sorry, proximal. Relative to the body, it's proximal to the axis. So, I'm going to have my internal force there, and then this is going to read EAI. Or if you wrote down your acronyms the way I do it, I put RAF. So RAF or FAR, whether it's forward or backwards, doesn't matter. It tells me it's a first class lever. So now, if the reason why you can get this messed up is because if you were careless like I was at first, when I did this kind of quickly in lab, if you accidentally draw your insertion like over here and thinking that, oh, the tricep insert's way over there, and the load stays the same, right? Or the resistance, or external, we'll say external force and internal force. Now that changes the order. If you moved it from here to here, that changes the order of which this is, right? So now we're saying this is EIA. So EIA, that says that's a third class lever. But that was because we put our insertion a little bit too distal, right? It should have been here. And I know that because I know my anatomy. If I go back and refer to the skeleton or your anatomy app, like this is the one that I had recommended before. This is the Human Anatomy Atlas. I can look at these points and I can draw on it if I wanted to, right? I can just draw these, draw my axis, draw my insertion, and practice these joints so that it makes sense. Visualize it in your head. You don't have to memorize, elbow flexion and extension. That's third class lever. No, you want to be able to kind of be able to visualize this or draw it out and then figure it out. Just either memorize this or however you want to do it. That'll help you. Now, when it comes to mechanical advantage has to do with like your lever arms, right? And in our slides, basically said, what did it say? Mechanical advantage. Like second class is always greater than 1, and then third class is always less than 1. So mechanical advantage is the ratio of internal moment arm to the external moment arm. And so as a formula, that means the mechanical advantage is the internal moment arm divided by the external moment arm. Okay? So if I wrote that over here to my example, I'll just we'll do this example, the tricep elbow extension first. So we said there's my external force, there's my axis, and this, my anatomical correct insertion point, or the internal force, right? Now, if I were going to draw lever arms, my lever arm, if I draw my lever arm, that's going to be, let's pick a different color, blue. My lever arm is between the axis and wherever that load point lies. So that's my lever arm of my external arm. Lever arm and moment arm mean the same thing. Okay. And then my axis to my internal part, that moment arm, is here. And so these two distances are significantly different from each other. We could say, like, if we gave them values, just like some random number, we could say this one is going to be IA, right? We're going to say IA is like 2, and this one is a lot longer, so we'll just say it's 10, right? I said that my mechanical advantage is the internal moment arm over the external moment arm, right? So if I just put these like random values in here, I know that the internal was much smaller, right? So 2 over 10, that would be 0.2. And that number is less than 1, right? So what did we say in the PowerPoint? He put in the PowerPoint, where's it at? He said, first class is dependent. It depends on the axis point. It could be equal to, less than, or greater than. So it can be either of those. But he said, third class is always less than 1. So third class lever. So we'll draw a third class lever. We said elbow flexion. We'll draw our elbow flexion. So that's our external. This is our internal. And that's our axis, right? So let's do these distances. That's going to be my internal arm, moment arm. And this is going to be my external moment arm. And if I gave these some random values, I could pick I could pick the same numbers, or I could just like say this is 1 and then this is 10 or whatever. All right. So if my mechanical advantage is my internal moment arm over my external moment arm, so 1 over 10, right? So that's 0.1, right? I know that that's less than 1. So what do we say about third class, or what did he say about third class levers? They're always less than 1. So I know that whatever we just found is consistent with what it says in the PowerPoint. So that's all that really means, and how it comes into play is why lever arms are important is just basically the easiest example I can give is if you were to do like knee extension, right? So I'm going to draw knee extension. I'm going to draw some like doing a long arc quad or sitting in a chair, and then they have to kick their leg out, and that's their foot, right? So this is the way they're facing. All right. So they're doing knee extension, so the lower leg is going that way. Okay. If I were going to draw, go ahead and label my points, right? So that's my axis. I know the quad inserts at the tibial tuberosity, so it's going to be distal to the axis. And then my external force is going to be way over here. Let's just say I put a big old ankle weight right here and gave somebody a 5-pound ankle weight. And then that's my internal force of the quad pulling that way. And that's my AEI, so just for fun, AIE, in order, AIE, third class lever, cool. So I know that that's a third class lever, right? Now, if I want to draw the distance between these points, I obviously that the internal is way, way, way smaller than the external moment arm, right? Forgot to label that one. So if I were to just give these some like random values, again, we're going to do like 2 and 10. It's just easier. Mechanical advantage, again, I said is IA over EA, or the internal arm over the external arm. And I just plug those values in. So, right, 2 over 10 is 0.2. So that's definitely less than 1. And I said this was a third class lever, right? And then I double check myself with whatever that rule was. Oh, less than 1. Third class lever, less than 1. All right, cool. I'm happy. So that's what that means. And basically it just means if my if I put the ankle weight a little bit closer, right? If I put that ankle weight a little bit closer, it wouldn't be as hard to lift this up. And that's why basically if I gave you like, 20 pounds to hold, and I told you to hold it with your arms out straight, it'd be a lot harder versus if you held it really close to your body. It's because that lever arm, the longer that lever arm, the harder that is to lift, even though it weighs the same, regardless of whether you put that weight here or whether you put that weight here. That muscle has to produce a little bit more force because now we're talking like more leverage out here versus if like you put the weight, like just below the knee. So anyway, I hope that helped anybody who was like kind of confused or was frustrated trying to read the book, because I know the book didn't really go into that. All right. If you have any questions, just like hit me up on GroupMe or just ask me before or after class. So, but I know in lab he had said that tricep extension was a third class lever, but really it's a first. If you look at your insertion points, it is a first. So, all right.